In this lesson, we are going to take a quick look at setting up stereoscopic rendering in V-Ray. It's a very simple process to get a basic stereoscopic 3D rendering going on in V-Ray. In the Create panel and Helpers tab, if you choose V-Ray, you can add V-Ray stereoscopic camera helper, or you can do the same in the V-Ray toolbar. So select V-Ray stereoscopic camera helper in the V-Ray toolbar, and click once in the viewport to add the stereoscopic helper. Now let's go to the modify panel and see what we have here. The first thing I want to enable is adjust resolution. Right now the resolution we are rendering with is 800 by 800. If adjust resolution is disabled, the width value will be divided in half for the left and the right eye images. But if enabled, the width value will be multiplied by 2 and each eye image will be rendered in the full 800 by 800 resolution that we have here. Now, basically we are ready to render and see the result of our stereoscopic setup. And you can see the result in render 01. To see the actual stereoscopic effect, we can enable stereo mode in the frame buffer. Now we see the left and right images as red and cyan overlays, and if we were wearing proper anaglyph 3D glasses, we would have been able to preview the effect right here. Unfortunately, we cannot save out the render in the stereo mode, and we need to achieve this effect from our raw renders in a post-production application. Let's get back to the stereoscopic helper parameters and see what we have. Eye distance specifies the eye distance for which the stereoscopic image will be rendered. 6.5 centimeters is normally a standard value for human eyes. Now if you take a look at the frame buffer and make sure stereo mode is enabled, in the first render eye distance is set to 6.5 centimeters, and in the next render it was set to 13 centimeters. Let's make sure eye distance is set to 6.5 centimeters. Next we have specify focus, which when enabled defines the point of focus with the focus distance parameter down here. We have focus method to specify the focus method for the left and the right views. Let me read you the description for these different focus methods from the V-Ray's guide. When set to none, both cameras have their focus point directly in front of them. When set to rotation, the stereoscopic effect is achieved by rotating the left and right views so that their focus point coincide at the distance from the eyes where the lines of sight for each eye converge. We have shear. In this mode, the orientation of both views remain the same, but each eye's view is sheared along Z so that the two frustums converge at the fusion distance. We have inner ocular method, which specifies how the two virtual cameras will be placed in relation to the real camera in the scene. In the frame buffer, let's take a look at different inner ocular methods as I explain them. Shift both. In this mode, both virtual cameras will be shifted in opposite direction at a distance equal to half of the eye distance. We have shift left. In this mode, the virtual cameras are shifted to the left so that the right camera takes the position of the original camera. The left camera is shifted to the left at a distance equal to the eye distance. And shift right, in this mode, the virtual cameras are shifted to the right so that the left camera takes the position of the original camera. The right camera is shifted to the right at a distance equal to the eye distance. For now, let's use shift both. We have adjust resolution, which we discussed at the start of this lesson. Let me show you two renders with adjust resolution enabled and disabled again. In the first render, adjust resolution is on, and in the second render, it is off. Let's make sure it's enabled for now. Output layout specifies the format in which the stereoscopic renders are output to the V-Ray frame buffer, whether side by side or top to bottom. Show cones controls when to show the cones of the virtual cameras created by the stereo reg, which will be discussed briefly later on in this lesson. And in the shade map parameters rollout, you can speed up the rendering of your stereoscopic image. First, you set the mode to render shade map. Then you define where you want to save the shade map. Then you render your scene and the shade map will be saved out. And then you change the mode to use shade map and use the saved out shade map in the shade map file down here and render your scene again. And it will be faster this time. And this shade map file contains basically information about the important visible shaded points in the scene. Reuse threshold affects the rendering with shade maps. Lower values will make V-Ray use less of the shade map and more real shading. The shade map are saved out to 16-bit images. If you turn on 32-bit, they will be saved as 32-bit images. And we have exclude, which allows the user to exclude some of the objects in the scene from being rendered with the shade map. And finally, we get the panoramic pole merging. And if I quote again, the options in this section are used when rendering a panoramic view, like we learned in our previous lesson with camera types, with, for example, spherical panoramic camera. So in this section, the options are used when rendering a panoramic view with stereoscopy. Okay, these options allow us to avoid artifacts when looking upward and downward. This is achieved by gradually decreasing the eye distance and thus the stereoscopic effect. The eye distance value is kept the same until the viewing angle reaches the angle specified in the properties below, after which the eye distance is gradually decreased until it reaches a value of 0 when looking directly downwards or upwards. Those two parameters are top and bottom merge angles, which basically control the viewing angle at which the pole merging effect described above starts. We also have a V-Ray stereo rig which can be created from the System tab. V-Ray stereo rig can be used in cases where the left and right cameras are defined separately. For example, when their animation is predefined from motion capture data. Okay, so we have the left camera, the right camera, and the main camera. Obviously, this was a very brief introduction to stereoscopic rendering, but hopefully it is going to be a good starting point for you. Okay, see you in the next lesson.